Alright, the next section of chapter 8. These are the special right triangles. There's two types. They kind of have a trick to them. So they're ones that if you remember, then it'll save you a lot of time in having to do trig or Pythagorean theorem or something like that. Okay, so the first one, isosceles right triangle, we need to make sure we remember. Isosceles means that two sides are equal. So the two legs will always be marked equal unless they tell us, and then we can just mark them equal. Alright, so what are the angle measures of an isosceles right triangle? We know triangles add up to 180 degrees. It's already got a right angle, so we'll subtract the right angle off. And then these two angles have to be the same because the two legs are the same. So I'm going to divide by 2. That gives me 45 degrees. So that means this triangle has a 45 and a 45 and a 90. And that just happens to be its other name besides isosceles right triangle. It will be a 45, 45, 90 triangle. So the theorem for this is that both legs are congruent and the hypotenuse is root 2 times the length of a leg. So I made my legs s's here. So it'd be an s and an s, and then the length of the hypotenuse is s root 2. Okay, and if you do Pythagorean theorem here, that's what you'll come out with is s root 2. We really don't need numbers. But just picture, like, for example, I give you a 7. Your s is 7. So that makes your hypotenuse 7 root 2. No Pythagorean necessary. Only for isosceles right triangles. Alright, so let's try this. It's a 45, 45, 90. So that means if this one's 9, then that one's 9. And h is 9 root 2. And if you don't believe me, do some math to it. 9 squared plus 9 squared equals h squared. This is 81 plus 81 is 162. And then you take the square root of both sides, and you should get 9 root 2. Either way it works, it's just my way's a little quicker. Alright, same with this one. We've got 45, 45, 90. If this side's 2 root 2, then this side's 2 root 2. And then the hypotenuse is the side times root 2. So then we have to do a little math here. That'd be 2 root 4, so that's 2 times 2, which is 4. So x is 4. Alright, this one they didn't give us any picture or anything, but they tell you the legs are 5 root 3. So that means the hypotenuse, we'll put h for hypotenuse, is 5 root 3, the length of a leg, times root 2. So that gives us 5 root 6. Okay? Math today is not too challenging. I haven't touched a calculator yet, so you should be able to do this without a calculator. Alright, we want the value of x. This one's a little different. X is a leg this time. So that means you got an x and an x and a 6. This would be this side times root 2. So x root 2 equals 6. Now I'll show you two ways to do this, because one way may be easier than the other for you. Okay, so we know x root 2 is the 6. So you divide both sides by root 2. So you get 6 over root 2. And in algebra, we cannot leave a root on the denominator. So you multiply by 1. But your 1 happens to be square root of 2, so we can get rid of that. Okay, watch what happens. 6 times root 2 is just root 2. Root 2 times root 2 is root 4, which turns out to be 2. And then the 6 and the 2 reduce, the top and bottom, so that comes out to be 3 root 2 for your x. Okay, another way to do this one, I'll show you another way, is you could do x squared plus x squared equals 6 squared. Pythagorean theorem. You get 2x squared equals 36. You divide by 2, you get 18. And then you take the square root of both sides, and you get 3 root 2. Either way, it doesn't matter. The top way, some of this math can be done in your head or in a calculator. It just depends on what you look at. Down here, some of that math could be done in your head. So it just depends on how you want to tackle it. All right, a word problem, because I like softball, so we'll do that. A high school softball diamond is a square, in all honesty. The distance from base to base is 60 feet, so every base path has to be 60 feet. When we measure out at the ballpark, it has to be 60 feet all the way around. So to the nearest foot, and I'll make this a different color, how far does my catcher throw from home to second to throw a girl out? And you know, bases are squares. It just so happens they make the right angles on the bases. So then, this is an isosceles right triangle, or it should be. So when Emma goes to throw this down, she throws 60 square root 2, because that's an isosceles right triangle. That's how that happened. But, in all honesty, do I really say she threw 60 root 2? That doesn't make any sense. So when we put it in our calculator, she actually throws 84.9 feet. And she's probably got a reaction time of about a second and a half, 2 seconds tops. So she's throwing that fast in seconds. So that's a pretty good catcher if you ask me. But, you know. Alright, some gardening, because my sister's a gardener, so I always have to do that. We have a square garden, so let's draw a square. Making a square garden. And it has sides that are 100 feet long. Okay, so every side of the garden is 100 feet, otherwise it wouldn't be square. And I want to build a brick path along the diagonal of the square. And how long will the path be? Knowing this is a square, those are right angles. So this is an isosceles right triangle. So then this side would be 100 root 2. But like the previous problem, we don't talk about roots whenever we talk about gardening. So we put it in our calculator, and we get 141.4 feet. It's actually a little bit above 141.4, but that gets us pretty close. So then we could go through and figure out how many bricks wide we want, and then we could calculate how many bricks that we need in order to finish the project. Alright, the other trick of the day. So that was isosceles right triangles. That's just how they work. The other one's a little bit trickier to figure out, but I think you can do it. It's a 30, 60, 90 triangle. So this is a triangle that has a 30 degree, a 60 degree, and a 90 degree angle. If it has any other angles, this trick will not work. Okay? So in this triangle, the length of the hypotenuse is twice the length of the shorter leg. The shorter leg is opposite the 30 degrees. Okay? Sometimes you can tell and sometimes you can't. It just depends on what you're looking at. So then the hypotenuse is twice the smallest side. And then the longer leg, the one opposite the 60, is the shorter leg times root 3. Okay? So it's 1, 2, square root of 3. Alright, so let's try a couple of these. So first thing I want you to figure out is where the smallest side is. So here's the 30. So we go across. That one's the shorter side. So then the hypotenuse is twice the shorter side. And then opposite the 60 is shorter side times root 3. Okay, that gets all of our thought processes going. So we need to start with how the d root 3 has to be 5. Okay, and we need to do some math here. So we divide by root 3. We get 5 over root 3. And if you remember the trick from before where we multiply by 1, we get 5 root 3 over 3. It's ugly, but it's there. Okay? So then this side right here would be 5 root 3 over 3. Okay? So then f is twice that ugly thing. So if you plug that in your calculator, you'll get 10 root 3 over 3 because you're just doubling it. Okay? The math's not that challenging if you really think about it, but it does look intimidating. Alright, let's try another one. Okay? So you look at the picture, you say, where's my smallest side? So go to the 30 and go across the triangle. That's your smallest side. So then opposite the right angle would be twice your smallest side. And then opposite the 60 would be smallest side times root 3. Okay, so if x is my smallest side, hypotenuse is twice the smallest side, and it's 8, that means x has to be 4 in order for that hypotenuse to be 8. And then down here would be 4 root 3 because x is 4. Okay? Just a couple of little tricks to get you going.